And as we get the computer switched out, I want to bring up Ryan Herringa. And Ryan comes to us as an assistant professor of child and adolescent psychiatry at the University of Wisconsin School of Medicine and Public Health. And Ryan is unique because he is a pediatric psychiatrist and neuroscience. And he's really he's structuring his work around brain mechanisms of trauma and PTSD. And Ryan also, I think, single-handedly, I might be wrong, let's look around the room to make sure, but he single-handedly brought back the coolness of the bow tie. So, you know, it used to be kind of an old man thing, but not anymore. So let's, a media guy? Yeah, let's see the whole thing here.
You want the whole thing?
Oh, he has to reset it. Thank you, Ryan. And you can choose if you want to hold this or click this.
Yeah, let's try this to see if that works. All right, let's see. Can you guys hear me okay? Is that loud enough in the back too? Excellent. Okay. Let's try this again.
I think he has to reset it.
Looking better. Okay. Well, thanks a lot. It's great to be here. Thanks to Jenny and Marty for the invitation. Really quite an honor to present here and to be doing so alongside of folks like Marty and Victor and Mike, who've really been leaders in this field and have influenced my work as I've gone along. So I'm going to be talking to you guys today about disruptions or alterations in the brain's fear circuitry in cases of pediatric trauma and post-traumatic stress disorder. And along the way, I want to try to incorporate some of these ideas of what may be adaptive versus maladaptive changes that Bruce touched upon so nicely this morning and other speakers have been threading through their talks. I think this is really an important piece to understand that we haven't quite fully grasped yet. Before I go further, I don't have any potential conflicts of interest to report, at least that I'm aware of. I do want to acknowledge my funding sources, including NIMH, NARSAD, and ACAP, without which this work would not have happened. So here's a brief outline of what I'll be talking about today. I'm going to give you guys a bit of an overview of the brain's fear circuitry, the fear network. It's going to be a simplified version, so hopefully the neuroscientists in the room will forgive me for doing that, but I want to make this very accessible along the way. If you guys don't understand certain terms or jargon or findings, raise your hand, shout out. I don't know, is that okay, Jenny?
I'll be the shout.
Okay. So after that, then I'll show you some findings looking at the correlations and potential effects of childhood maltreatment itself on fear circuitry, and finally on fear circuitry in pediatric PTSD. And I think Mike set this up really nicely, showing you a lot of interesting data on structural brain differences in maltreated kids and kids with PTSD. I'm going to be focusing primarily on brain function and functional connectivity, which I'll explain a little bit more as we go for those of you who aren't familiar with it. All right, so here's some neuroanatomy for you. This is a simplified diagram of the brain's fear circuit. And we're looking at the brain as if you had sliced it down the middle of my head this way and looking from the side. And so on the left side is the front of the brain. On the right side of what you're looking at is the back of the brain. And there are important regions that we talk about in terms of fear responses and regulating fear responses. Most of you are probably familiar with the amygdala. This is one of the brain's emotional hotspots. It's involved in detecting important things in the environment, including potential threats. and salient things in your environment more generally, and feeding that information to other areas of the brain so that you can decide how to respond in any given situation. So there are areas of the brain, though, that can both promote and inhibit fear responses. And so one of these areas, the dorsal ACC, or anterior cingulate cortex, really acts as more of the gas on the system. So it will promote fear responses, presumably through potentiating amygdala-based fear responses. But there are other areas of the brain that act more in a regulatory or inhibitory role. And one of those is the VMPFC, which Mike talked about, or the ventromedial prefrontal cortex. So both of these are more automatic regulatory circuits for modulating amygdala-based fear reactions. The VMPFC, as Mike hinted at, is very important in breaking or inhibiting automatic fear responses. It's also very important in what we call fear extinction. So once the danger has passed, can I begin to get rid of the fear, the anxiety associated with a traumatic memory with time? So that's what we normally do, and this is a region of the brain that's highly important in doing that. It's laying down a new emotional memory, a safety memory, if you will. Now, there's also an area called the hippocampus, which again, I think many of you are familiar with in its role in learning and memory. It's also very important in regulating fear responses. Christine and others talked about its role in neuroendocrine regulation of fear and anxiety responses earlier. It's also involved more behaviorally as well, in that it can put a contextual limit on when a fear reaction occurs. So it takes in information from the surroundings and says, has something bad ever happened in this room to me before? And so do I need to open the floodgates on the fear response, or can I shut them down? Because this has been, at least in my experience, a safe place. Now, finally, there's another area I want to mention called the dorsomedial prefrontal cortex, which Mike mentioned as well. So this area, along with more lateral or outside regions of the prefrontal cortex, are involved in more conscious, effortful regulation, and more generally are involved in things like executive control, organization, inhibiting responses, and also effortfully regulating emotional responses, including fear reactions. And so we'll talk more about this as we go along. Now, how might these circuits become dysregulated? How might fear be potentiated? This is one model that's been put forth through primarily studies of adult anxiety disorders and PTSD, which would suggest that we have an amygdala that's hyperactive or hyperreactive to emotional stimuli, particularly negative stimuli in the environment, but that there's also this feed-forward process with the dorsal ACC where that fear response gets further potentiated. At the same time, the fear inhibitory or gating areas of the brain are taken offline to some extent, or at least not working properly. And so you have a relative loss of contextual limiting by the hippocampus, a loss or a weakening at least of this inhibitory, automatic fear inhibitory connection through the VMPFC, and then perhaps a loss of more central executive control more generally of emotions. But, of course, as Mike so nicely pointed out, kids aren't just little adults. We're dealing with brains that are under development. And that means that they're both plastic, but they're also particularly sensitive to the effects of stress and trauma over these time periods. And here are just some examples showing structural brain development in some of the regions of the fear circuit that we're talking about. So on the left, we see hippocampal volume increasing in boys and girls very dramatically up till the age of 10, and then a much slower increase in growth thereafter. On the right side is shown studies from Jay Geed showing that cortical thickness changes over time, this ranging from 5 years all the way into mid-20s. And what I want to highlight here is that one of the last areas of the brain to thin, so cortical thinning is actually a normal developmental process. So one of the last areas to thin are these CEO regions of the cortex, the dorsomedial, lateral areas of the prefrontal cortex. And so you can imagine that these regions may be very sensitive then for quite some time. By the way, any of you who have high schoolers, or my apologies to any undergraduates in here, but it's not quite cooked yet. It's got to bake a little longer. You'll get there. So not only are there structural developmental changes in the brain, but there are functional developmental changes in the brain as well. And these are really studies that have only come out in the past couple of years. If we look at, for example, amygdala activation, so that's shown in the top row here. What these previous labs have found, or what these labs have found in previous studies, I should say, is that amygdala activation actually decreases with age. So these are cross-sectional data. And in that middle column is shown the amygdala response to fear faces. There's a similar profile that you see for emotional pictures, whether it's negative or positive pictures. Amygdala activation reactivity decreases with age. Now, we think this is due to greater coupling between the amygdala and some of these inhibitory areas of the prefrontal cortex, like the ventromedial prefrontal cortex, as kids age. And indeed, there's evidence of that from these same studies. If you look in the bottom row, these are profiles of coupling or connectivity between the amygdala and the ventromedial prefrontal cortex, both suggesting in their own way that that coupling becomes stronger that the older kids are. We can perhaps talk about why those slopes look different in the faces versus pictures, but it's a more complicated question we can maybe leave for later on. By the way, I am going to be talking a lot about functional connectivity. And for those of you who aren't familiar with this technique, we're using functional MRI to look at brain activation, but not just in one spot. We're looking at coordinated brain activation between two different regions of the brain. So do they go up together or down together? If so, then they're correlated in time. And that's how we infer functional connectivity, that these areas may be communicating with either at rest or when we have participants do a certain task. Okay, so what do we know about childhood adversity and how it may affect brain structure and function? Mike reviewed some of this. I'll just touch on it briefly here. We've seen evidence that childhood adversity, including trauma, including maltreatment, is associated with lower or smaller volumes of the hippocampus, of prefrontal cortex regions. With regards to brain function, we see fairly consistent evidence of increased amygdala activation, increased activation in the dorsal anterior cingulate, again, one of these fear-promoting regions of the brain, as well as dorsal prefrontal areas, and then perhaps decreased activation in more lateral areas of the prefrontal cortex. Now, not much is known, really, about the brain's functional connectivity and how that may be altered following childhood trauma and or PTSD, and those are some of the data that I'll be getting to shortly. And importantly, as I go through these findings, I want to consider and have us all think about which of these changes that I'm describing, differences or alterations, may be adaptive versus those that may be maladaptive. So some of these processes or changes may be quite helpful in these kids or these now adults in surviving in their environment and escaping potential future harm, whereas others may contribute directly to psychopathology, mental illness like PTSD. So a couple of years back now, we looked at the relationship between childhood maltreatment experiences and resting state functional connectivity of both the amygdala and the hippocampus in a community sample of adolescents. This is part of a longitudinal community study of 132 adolescents in collaboration with Marilyn Essex and Richie Davidson at Wisconsin. And what we found is that childhood maltreatment experiences, as measured by the CTQ, you've heard about this questionnaire from earlier talks, were associated with a weakening of these automatic fear inhibitory connections. So connectivity between the amygdala to the ventromedial prefrontal cortex, as well as connectivity from the hippocampus to the ventromedial prefrontal cortex. We also saw that these mediated, at least in part, but certainly not entirely, some increase in internalizing symptoms by late adolescence at age 18. I should mention these kids were all 18 at the time of which their brains were scanned. Now, interestingly, so again, the question is this adaptive? Is it maladaptive? We got at this question in part through a study that I conducted at the University of Pittsburgh while I was still a fellow there, looking at a sample of 28 young adult combat veterans. And we asked, how do childhood maltreatment experiences versus combat exposure versus combat PTSD, how do all of those differentially predict functional connectivity of the amygdala and hippocampus? And what we found, nicely consistent with the last study, is that their childhood maltreatment experiences, again, predicted weaker connections in this automatic fear inhibitory circuit. So both from amygdala and hippocampus to ventromedial prefrontal cortex. But when we looked at combat PTSD symptoms, we saw something different. And again, this is adjusting now for effects of childhood maltreatment. What we saw here was that combat PTSD may be a result of loss of the CEO circuit that I talked about, this executive regulatory circuit. And by the way, this area is normally negatively connected or anti-correlated with the amygdala. And what this suggests is that a loss of that negative or inhibitory connection may be what sort of unleashes broader psychopathology like PTSD. So just to summarize, we've seen in these resting state functional connectivity studies that childhood maltreatment experiences may weaken these more automatic fear inhibitory connections. This may be partly adaptive to a degree in that it may allow a more immediate or heightened fear reaction or detection of potential threat, and perhaps release some of the contextual limitations on having that response too, with the hippocampal connectivity also being weakened. On the other hand, loss of these more CEO or executive type connections may be the maladaptive response following a trauma, and perhaps that's one of the sequelae that ends up leading to expression of mental illness like PTSD. So we've looked at some of these studies now, either in late adolescence and adults, looking at effects of childhood maltreatment. Do we see similar disruptions in pediatric PTSD? And to answer this, over the past couple of years now, we've been conducting a study called the Youth Trauma Study at the University of Wisconsin, where we've been recruiting kids between the ages of 8 and 18 with PTSD as diagnosed by DSM